called syllogisms. Right? So far we've covered in vocab, we've had a couple of classes. In verbal logic, we opened a new topic called parajumbles. This was last week. And on the other hand, Praddy did RC and a bit of grammar. And this week he will continue with RC and grammar, and we'll move ahead with verbal logic. So this is your second topic of verbal logic, syllogisms. So when we get started with syllogisms, we need to understand that any argument which is given to us, and this is not an argument which you are going to have with your friend or your sister or brother or your parents. An argument is an author's point of view, something that he is telling us about. Right? It could be on any topic. There are various topics which come up as arguments. And it consists of two parts. One part is a premise, which is given to us. It is statements which we have to accept as true. Actually, they may or may not be true in the real world. Okay, so if a premise or an argument tells you apples are blue, this is something that we have to accept. We can't say that I have never heard of a blue apple. A premise is always true. Yeah, for the sake of the argument. Outside, of course, we know the reality is that we haven't seen blue apples. But this may be one of the statements we have to accept, right? And given the premise, there is a statement called conclusion that is drawn on the basis of the premise. So we have one or more statements which are premise, and we have our conclusion. So let's take some examples. Yeah. Now this is something that we are given. Two premises. All cats are dogs. This is premise 1. And this is premise 2. Rocky is a cat. Now remember what I said. We know all cats are dogs cannot be true. But for the sake of the argument, we have to assume all cats are dogs. Okay. And for our question in the exam, what we have to judge is if these both premises are true, then is this conclusion valid or not? So that is what all of our questions need us to judge. Valid or invalid. So if Rocky is a cat and all cats are dogs, then by extension, does it mean that Rocky is also a dog? Can it be called a valid conclusion? Yes. So this is a valid statement. Okay. So this is all the concept there is in arguments. We will be given one or more premises, and based on the premises, we have to judge whether conclusion is valid or invalid, right? So if we can say that the conclusion follows from the premise, yes, this is true, then it is a valid argument. And if it doesn't follow, it is an invalid argument. So let's try to do a bit of simple practice. Let's start with easy questions, and then gradually we'll make it more and more difficult. Yeah. So this is one argument. Huh? This is premise 1. This is premise 2. And since this sentence has a therefore, this becomes your conclusion. So is this a valid argument? There are 25 CDs on the top shelf and there are 14 on the lower shelf. So 25 plus 14, 39. Now the bookshelf may have other shelves. We don't know. We are not given how many shelves the bookcase has. But there are no other CDs in my bookcase. This is given. So even if the bookcase has other shelves, the CDs are only 39. There are not more or less CDs. So given these two premises, can we say that there are 39 CDs in my bookcase? Yes. This is a valid argument. So we have combined premise 1 and premise 2 and the information which is given to us. and reached a conclusion that 25 plus 14, 39, and no other CDs. This was important because in the absence of this statement, there could have been other shelves with other CDs. So maybe we may not have been able to make this conclusion. But when this is specified as a premise, then we can say, yes, there are only 39 CDs and not more, not less. So this is a valid argument. Yeah, let's see one more. Right. So sometimes when you're trying to judge arguments, and we'll use this method sometime in this class also, but otherwise I like it when you can express the argument in the form of a picture. It makes it a bit easier to understand. Right. So Topeka is either in Kansas or Honduras. So this can be Kansas or Honduras, either one. This is premise one. If Topeka is in Kansas, then Topeka is in North America. So if it is in Kansas, we get North America. This is premise two. And if Topeka is in Honduras, then Topeka is in Central America. This is premise three, right? So we are just told this one or this one. If this one, then North America. If this one, Central America. Is this information helping us judge where it is actually? No, because it was an or statement to start with. So can we say therefore Topeka is in Kansas? No. There is nothing in these three premises that is helping us take a definite conclusion that Topeka is either in Kansas or Honduras. Yeah, where it is exactly, we don't know. So this is invalid argument. Okay, so now you all are getting it. I think all the answers on the previous one were, maybe few had replied invalid, but it was valid. In this one, I think there is no one who has replied valid, all are invalid. So now we are getting how to judge whether argument is valid or invalid. From the premises, does the conclusion follow or does it not follow? Is there enough in the premise to prove the conclusion, or maybe we need more information, or other situations are possible, and what the conclusion is saying need not be correct? If there's any situation like that which need not be true, it becomes an invalid conclusion. Now I'm going to make it slightly more difficult, changing the game a little bit. Two statements, so two premises, and two conclusions, which have to be treated individually. And now you have to choose from one of these four options. Great. So I'm really happy with the number of responses and the energy on the chat. So keep it up, not just in my class, but throughout the week. Try to keep up your energy. Maybe it's the first class, early morning, so everyone's fresh. Yeah. So all students in my college are intelligent, and Shreya is not intelligent. So like I said, can we make a visual representation out of this? Makes it much easier. Yeah. All students in my college are intelligent. Suppose this is a circle of intelligent students. Yeah. And there are many students in it who are intelligent. All students of your college. So this is my college. And all the students in it are within the larger circle of intelligent students. So there might be other colleges also who have intelligent students. But from your college, all are intelligent. And Shreya is not intelligent. So Shreya is somewhere here, outside. She's outside the circle for intelligent students. So if you're outside the larger circle, does it mean you are also outside the smaller circle? Yes. No part of this smaller circle can be outside. So Shreya is definitely not from my college because she is not intelligent. So this is okay. This is valid. Shreya should study more. Is the author within the premises talking anything about how to improve your intelligence or whether Shreya needs to become intelligent to get into a college? No. We only have to concentrate on the statements that are told to us and try not to go outside of the scope of your statements, right? So author has commented upon intelligence level, not how to improve it. So Shreya should study more is something that is outside the scope for us. This is not a valid statement, so our answer becomes 1. Only 1 follows. So based on these two premises, you could judge that Shreya is not from your college. This is a conclusion that you can draw. Okay. So is this simple? It's doable. Anyone has a doubt so far in what we've covered? So my classes are only going to be practice, as much practice as we can get. Different types of question which appear in your examination. So let's do a few more of this type. So Taj Mahal will survive the threat of acid rain. This is premise 1. It has stood the test of time for many centuries. This is premise 2. So in premise 2, the author is telling us since the Taj Mahal was built, it has stood the test of time. It is still there. Yeah. So premise 2 is talking about past. And premise 1 is talking about Taj Mahal will survive the threat of acid rain. Therefore, it is talking about future. So that's it. 2 statements, one about the past, one about the future. But is the author commenting upon acid rain and where it falls? No, it is purely about Taj Mahal. So acid rain is not common in many parts of the world, is outside the scope of your 2 premises. Yeah, we only have to concentrate on what the author is telling us. So this is invalid because we can't judge this. Now come to the second one. Some have chosen 2 in this one, some have chosen 3. Acid rain may damage parts of the Taj Mahal. But we are told in one of our premises that Taj Mahal will survive the threat of acid rain. Okay. The author has made a prediction about the future in his premise, and premise is always true. We cannot contradict the premise. We have to accept it. It may not be true in the real world. Actually, we know it is getting damaged. And if the premise said Taj Mahal is in Mumbai, we have to accept Taj Mahal is in Mumbai. Okay, not Agra. But here he's saying will survive. So statement 2, conclusion 2 becomes contradictory to this. Right? This is a contradiction. The premise can never be false. If acid rain may damage parts, then it will not survive, no? So as it is a contradiction, this conclusion becomes invalid. Premise is always true. So if Taj Mahal will survive the threat of acid rain is being told to us, then this conclusion cannot be valid. Right? So the answer here is neither 1 nor 2. right? Any doubts? Anyone who's not understood or who wants me to explain again? Please ask her. It's okay if we want to go a little slower, completely fine. This is a type of question which is slightly confusing, especially when the statements get longer. Right? I have one example of that on my slides. So 516 wants to explain again. So first one is understood. B516. Acid rain is not being spoken about in this topic. It's more about the Taj Mahal. So first one is out of scope. So this one is eliminated. And hence this one is also eliminated. We are only trying to judge acid rain may damage or not damage parts of the Taj Mahal. Right? But it is given in premise 1 that Taj Mahal will survive. Yeah, you're right, Sampath. They are saying it is a threat, but the threat will not affect the Taj Mahal is what is given in the premise, right? And this is will survive. So that is important. The wording is important. Will survive, they are saying that it will not be affected. So therefore, acid rain may damage parts of the Taj Mahal becomes an invalid conclusion because they are specifically told us in the premise it will not damage. So this is an interesting question. What if we have may instead of will in premises? So here if you had may, the Taj Mahal may survive the threat of acid rain. Yeah, then this becomes a valid conclusion because there's a possibility it may survive, it may not survive. So in the second possibility, it may damage. So this becomes a valid. If both are may, it becomes valid. Sure. Good, but good doubt and good situation also, which you have said. Good. So the accuracy level on this answer is really nice. I think we are around 85-90% of you all have got it right. That's nice. Just wondering, have you all done these questions before in class? But topic has been taught, right? From the concept perspective, I think you guys have faculty which have covered critical reasoning, conclusions, assumptions, syllogisms. Yeah, okay. So you guys know the basics. Parents are prepared to pay any price for an elite education for their children. Now, this is just one premise, and it mentions parents are prepared to pay any price for an elite education. Elite is a very good school, however expensive it may be. Right? Now, prepared to pay any price means that they will be prepared to pay any amount of money. But is anything mentioned about source of money? No. Either they already have the money or they are earning well and they will pay, or they may take a loan and pay. But actual source of money is not mentioned. So from this statement, can we judge that parents are well off? No. This is something that cannot be judged because the author has not commented upon where the source of money is coming to pay for it. So this is invalid. And parents have an obsession for the perfect development of their child through good schooling. Yes. But this is why they are willing to pay any price for an elite education. So this is a valid conclusion. So here we have only two follows, not the others. Okay, but I'm really happy that from the answers that I got, I think 85, 90, maybe above 90% accuracy. Very nice. Now, slightly longer one, an interesting one. Acha, some have not understood the meaning of entice. So, entice is to tempt or to draw out. I'll explain the passage, no worries. In all of my slides, guys, please ask meanings of any words which are not understood, put it in the chat. Not a problem. We'll explain. So, through a business front, it had funded. We don't know who it is or what it is. Yeah? What is a business front? A business front is a fake business. To the customer, it may appear as if it is a business, but behind there are no actual operations. It's just a front. It's a store, but at the back, there's nothing. Yeah, through a business front, it had funded and staged the conference at an unsuspecting foreign center of scientific research, inviting speakers and guests and planting operatives among kitchen workers and other staff. Operatives suggest that it is some sort of a, like the FBI or the CIA, some secret service organization. We've all seen movies, no, about this secret service, those who are protecting their countries, but they are not the police, they are the secret service. So the operatives word suggests that some secret service organization has put up a fake business, arranged a conference at some foreign location. Unsuspecting is not likely to raise suspicion. Yeah, so no doubts will be raised about it being a fake business. So it could entice the nuclear expert. Entice is to tempt or to draw out of Iran. So some secret service organization wants to pull one of the nuclear experts out of Iran, separate him for a few minutes from his guards, and pitch him one-to-one. What does pitch him mean? It may be that they want to pay him to defect or to come out of Iran, to not help Iran's nuclear program, maybe. Yeah, we don't know. So there are a lot of unknowns in this. But what we know is some secret service organization has put up a fake business, and the aim is to draw out one nuclear expert out of Iran and talk to him for a few minutes, maybe asking him to come to their country or pulling him away from Iran, preventing Iran's nuclear plan to go ahead. Does it mean that scientists have to work as kitchen workers in order to enable the research? No. This is just a front of a sham that was set up, and operatives were planted among kitchen workers, not scientists. The aim was to get this scientist out of Iran. So this is invalid. And Iranians are experts in the field of nuclear research. Can we say this? There is one nuclear expert who is being pulled out of Iran for some reason, and this secret service organization doesn't want him to continue working for Iran. But we don't know where Iran's nuclear strategy is. Is it working? Is it not working? Are they doing well? Are they close to making a bomb or something? That is not told. So Iranians are experts in the field of nuclear research is too far a conclusion to go, right? We just know there is one expert, that's it. And we don't know how good he is. That is not told. So this is also invalid. Answer here becomes 3, neither 1 nor 2. Yeah. So some doubts on planted operatives among kitchen workers. So Shravya, what this means is they set up a fake business and they put up a fake conference, right? Now, the Secret Service wanted to be present at the conference, so they can't put their guards with blazers and walkie-talkies and all, no, because it will then raise suspicion, and Iran will not send their expert to the conference. So instead, they have planted undercover operatives, undercover police, part of their Secret Service organization, who are pretending to be the chef or the waiters or kitchen workers and other housekeeping staff. Yeah, they are all undercover. So this is what it means, planted operatives among kitchen workers. So if required, they can always take action, or they can pull the nuclear expert away and all that. Maybe kidnap him. Yeah. Okay. So this was fun. A little bit of a story types, not sentence and conclusion, but more of a passage. So I have more of these. We have one more class on critical reasoning, where we'll be studying such types of problems. We'll have a fun statement, a very short passage, 50 words, 100 words kind of, and we'll have some options. What is the conclusion? What is the assumption? Can we strengthen or weaken? Something like this. So we'll continue this in our critical reasoning class. But meanwhile, I want to move to a subset of this type of question called syllogisms, right? So far we did few questions which we only had to rely on our knowledge of English. Read the passage, judge whether it is appropriately concluded or not, whether the conclusion follows. Some questions become a little difficult to answer only by figuring it out in your mind. Yeah. And then we need to use Venn diagrams. Now, Venn diagrams is something that we've studied before. It is set theory. A union B, A intersection B. We've drawn the sets on the screen, whether it overlaps, whether it not overlap, whether they are the same or whether they are completely separate, mutually exclusive events, right? Yeah, those who studied it, anyone who studied this before? Set theory and Venn diagrams? You guys will relate a little bit to what I'm going to take you through. So continuing in our line of questions, the conclusion type of questions sometimes need to be solved using Venn diagrams when they become a little confusing. So before we get into those questions, let's just quickly go through how do you represent this type of statement. So I have 3 statements which I want to represent on the screen. Yeah. First will be no A or B. So this is a circle which has all A's in it. All these elements are called A. This is a circle which has all B's in it. All these elements are different from A's. Might be different shape, different color, something different. Yeah. No A or B suggests that there is no common element between them. These two circles cannot overlap. B's will always be different and A's will always be different. Okay, this is no A or B. Any doubts in this? Anyone who's not understood? Now I'll give you a new situation. Let's look at what is all A or B. The simplest way to draw it is one circle. All A or B. So the elements within this circle are A as well as B. So each element is A also and B also. Each element is A and B. And what is the circle called? A equal to B. Okay, so I'll just go a bit slowly through this because I think some of the students have not studied Venn diagrams and set theory. So we'll have a look a little bit in detail. Okay, so when all the elements of one circle are both A and B, then A and B are the same. A equal to B. Both the circles are the same. They are a copy of each other. But when you are told all A are B, can there be any B which is not A? And then what does this circle become? A becomes a subset of B, right? Because all A are B, so if all these elements are both A and B, A is inside B, but these elements, there can be some B which are not A. These are all B, not A. If they were A, they would have been inside this circle, but they are not. They are in the larger circle. So these are all Bs, right? And all A or B can also be written in this manner, can be drawn in this manner, where A is a subset of B, but there can be a few Bs who are not As. So there are two situations which are possible for all A or B. If these Bs, which are not As, become 0, yeah, if there are no units which are not A's, this entire structure goes to this, A equal to B. Okay. So just going back to the previous slide, we're looking at no A or B. So just think about two shapes, right? One shape can be circle and one shape can be star, as we've drawn. And no circle can be a star, obviously, because the shapes are different. So if we put all circles in one group and call them A's, and once all the stars in one group and call them B's, can we say that these two circles will never overlap? They will not touch. They are called mutually exclusive events, right? Because these two shapes will always be different from each other. There are no common elements between the circles. So this is the meaning of no A or B. Okay. So we've covered no A or B, we've covered all A or B, and now we have one important situation called some A or B. And the most common way to draw it is to draw two overlapping circles. So if these are your circle for A's, and they have A's in it, and this is your circle for B, and they have B's in it, there are a few items which are both A and B, and they are in this area, the part of the circles which overlap has a few items which are both A and B, right? So this is some A or B. Okay. Now, what happens if those A's which are not B, these are the A's who are not B, yeah, they are outside B. If this becomes a null set, if all this entire section is 0, then only this circle is left, right? This circle is B and a part of it is A as well, right? So is there another way to draw this? Yes, Nalini has said it correctly. This becomes all A or B. This is something we drew on the last slide. This part, A's which are B's, has become this part. It has become a subset of B. And there are still some elements which are not A's. Right? Only when this became 0, we got these two diagrams. It went this way. Now what if this part becomes 0? So there are no B's which are not A's, but A's can exist. Now it goes in the other direction. We have this circle left, of which part are overlapping, which are both A's and B's, and the other part is only A's. Right? Now, B has become a subset of A. So can we draw this in another way? The larger circle can be A, and the smaller circle will remain B. And this is your shaded area. These are same diagrams, huh? This one and this one. It's only that the shaded area has moved inside the circle. That's it. There's no other difference. Same way, this one and this one. This shaded area here has moved inside the circle. Now, we can say all B are A, because we've gone back to the circle which we drew on the previous slide. So in this one, all B are A, and in this one, all A are B. Yeah, this is what happens when we start defining these two areas. B's which are not A's and A's which are not B's. What if both of them are 0? Then what happens? If both of them are 0, only this dark blue area is left. Na? Only this is left. And all of these elements are both A and B. So can we say A equal to B? This is what we had on the first diagram on the previous page. A equal to B. When there are no B's which are not A's, so this is 0. And there are no A's which are not B's. This is also 0. Then only this shaded area, this overlapping part is left, which becomes this, which becomes, can be drawn as a circle as well. So all of them are A equal to B. All are A and all are B also. Okay. So any doubts in this? Just a few basics of how to use Venn diagram to solve our problems. So let's get into a sample problem. Okay, this is with practice, it will become easier. And if some have not understood what I just drew, then the questions will make it much simpler to follow. Yeah. Okay. So let's solve. So this is a slightly different question, but we've solved it before. The only difference is that before we had things that we were doing in our mind. Sometimes it gets a little confusing. So that is why we start with the diagrams that we've drawn. As we get more and more practice, as we become faster, the diagrams that we drew start getting created in our minds. And that is a better way to do it. But right now, when the statements are confusing, it's okay to use diagrams to express what we want to say. Now, going back to what we studied at the start of our class, we have two premises, premise 1 and premise 2. These are our statements. And we have two conclusions, conclusion 1 and conclusion 2, which we have to consider individually, which means one at a time. Okay. So if only conclusion 1 follows, then we can select A or B or neither 1 nor 2 C or 1 and 2 both, right? So first let's consider premise 1 and premise 2. All cars are cats. How did we draw this in our diagrams? We had cars, which is a subset of cats. Yeah, all cars are cats. Now remember what I told you? Sometimes the premise is going to sound weird, but you have to accept it as true. You can't question. Yeah, all cars are cats. So there may be cats which are not cars, but for now, all the cars are inside the larger circle for cats. And can we take premise 2 and express it over here? All fans are cats. So again, we have one smaller circle for fans and we have a larger circle for cats. Can we combine these two premises into one pictorial representation, into one diagram? Yeah, we can have a large circle for cats and cars is also inside that circle and fans is also inside that circle. But between the two premises, we are not told the relation between cars and fans. These two circles inside cats, whether they are mutually exclusive, they are separate, whether they are slightly overlapping, which means some cars are fans, or whether they are exactly overlapping, which means all cars are fans. This has not been told to us. There is no relation given between these two. Yeah. So therefore, you can't judge whether all cars are fans. This becomes invalid. Some fans are cars. This also becomes invalid because you can't say. You don't have enough information to definitely prove that either all cars are fans or some cars are fans or no cars are fans. You can't. All we know is both cars and fans are inside the circle for cats. But the relationship between these two circles is not known. So here the answer is C. Okay. So this is how we solve. Just the first question. So don't worry if some of you all didn't get it. We have a lot of practice, another half an hour of practice. We expressed premise 1 and premise 2 as a Venn diagram here and here. Then we clubbed those and made it one Venn diagram. And then we tried to judge whether the conclusion can be true or not in the combined diagram. Okay, so follow this method, simple method, diagrammatic method. With practice, as we speed up, this should be done in your mind. But for now, if it is done on a notebook or some piece of paper, pen and paper, it's okay, no problem. So shall we solve? So let's try to do it. For those who are quicker, you can do it mentally. Okay, no problem. You can do it fast. For those who are just learning the method, or for those who, for whom the Venn diagram is a new thing, do it using the diagrams. Start practicing more and more, and then we can start doing it mentally. Okay. On our website, there are many more questions for this. So today evening again, on this same topic, there will be tests which are uploaded for syllogisms. Each question will have a recorded solution as we are solving it in class. Similarly, I will draw the diagrams for you, show you how it is visually represented, and find the answer. Okay, so those who solve the paper and those who don't get the answer, you can watch the video for each question that you got wrong, okay, how to solve. Similar type of video we have recorded for each question. Some scooters are trucks. So can we draw two circles? Some A are B. Remember what we studied? Some scooters are trucks, and I'm writing trucks as TRU because we have TRA as well. And these are the scooters which are trucks in this blue shaded area. Yeah. And all trucks are trains. So can we say there is another diagram in which these are trucks and all trucks are trains. So this is a subset of a larger circle for trains. Yep. This is okay so far. Now, can we club these two diagrams? So one way to club these two diagrams is that the scooters which are overlapping with trucks, we can put here. So these are the scooters which are trucks, this dark blue area. There is another way to make this the same diagram. This we extend into trains as well. So we can draw a bigger circle here, and this is the circle for trains. So all trucks are trains. This is this circle. There are some overlapping scooters as well, and it is inside a larger circle for trains. So both ways you can do. Any diagram is okay. We can put scooters here, or we can say trains is here. Okay. So we have premise 1 and premise 2 in the diagrammatic form here. Now we consider each conclusion. Some scooters are trains, yes, because this dark blue area has come inside the circle for trains. And also this dark blue area is inside the circle, the large circle for trains. Because all trucks are trains, so those scooters which are trucks, they will also become trains by extension. So this becomes valid. First one. Can we say no truck is a scooter? Is this conclusion a contradiction of premise 1, where it says some trucks are scooters or some scooters are trucks? So no truck is a scooter is a direct contradiction of premise 1, which is not allowed. Premises cannot be false. So in this case, it is only conclusion 1 follows. Yeah, first one was valid. Second one was a contradiction. So not allowed. Any doubts in this? Anyone who's not understood? Please ask her if you would like me to solve again. Now, I'm going to change the game little bit more. I'm going to make it slightly more difficult. I'm going to give you 4 arguments at once. And we have to judge which of those 4 are valid or invalid. And we have to choose the correct options. Okay, so let's go to question 3. Now, if you're seeing this type of question for the first time, in each argument, this is one premise, this is premise 1, this is second premise, and this is conclusion. And the argument is valid if conclusion follows from the 2 premises. So this you have to do for 4 statements. Right. So shall we solve? Anyone who's still solving, you can continue solving. Let's solve together. So each of these statements is an argument. Okay. So those who are doing it mentally, very good. You guys can proceed mentally. For those who are slower, I will explain using the diagram method, which is better to take a judgment of what is where. Can something overlap? Can it not overlap? Yeah. So some printers are fast. So we have our first basic circle for printers and circle for fast. And those printers which are fast are over here. And there can be other printers as well, those which are slow or those which are medium. And there can be other items which are fast, those which are not printers. Yeah? Fans can be fast, scooters can be fast, whatever. So both the circles can have other items. Only thing we know is some printers are fast here. And no fast is slow. So we have two circles, fast and slow, which are always mutually exclusive. They will never overlap. Okay, so some printers are fast and no fast is slow. Can we say from these two that no printer is slow? See, relationship between printer and slow is not given. Now, if we can combine these two into one diagram, you can say printer would have been here. Right? This same diagram I've taken here. But while we know some printers are fast, the printer can be here, it can be here, it can also be here. So some printers are fast is still true, right? These are those printers in blue. But in this situation, there are also some printers which are slow, which are this overlapping area. So whether it is this we are considering or this we are considering or this, we don't know, because the relationship between printer is and slow is not given. So this we cannot definitely say. No printer is slow cannot be guaranteed. I can't definitely tell you that printer and slow will not overlap. We just saw a situation in which it might, and we just saw a situation in which it may not. So this is not a valid argument. This is invalid. So A is eliminated. Now let's do the next one. No poet is a thinker. No poet is a thinker. Yeah, mutually exclusive. Always gap between the two. Some thinkers are leaders. Can we use the same diagram? Some thinkers are leaders. And these are the leaders who are also thinkers. So premise 1 and premise 2. Can we say no leader is a poet? In this diagram, yes, no leader is a poet. But actually, leader and poet relationship is not given. Leaders can be over here, leaders can be over here, or leaders can be over here. As long as some leaders are thinkers, they are all situations which can be true. But in this situation, there are some leaders who are also poets, these leaders. Right? And in other situations, there are no leader who is a poet. But we don't know which one of this is true. This can also be true. This can also be true. So again, this is something that we cannot guarantee. It becomes invalid statement. May be true, may not be true. Next one, same question. No poet is a thinker. Some thinkers are leaders. So let's use this. We already have it in front of us. Some leaders are not poets. This is a conclusion. Based on this diagram, can we always say that these leaders who are in dark blue here, because of the first premise that no poet is a thinker, this gap will always be there between poet and thinker. So those leaders who are overlapping with thinkers can never be poets, right? So some leaders are not poets will always be true. This is a valid argument. Okay. And your last one. Only cats are dogs, which means A equal to B. The circle is the same. Cats equal to dogs. All the elements in this circle are both cats and dogs. And this is premise 1. If no cat is a pig, that means pig is a separate circle. And it cannot overlap with this circle because no cat is a pig. Does it also mean that no dog is a pig? Yes, because the circle for cats and dogs are exactly the same. So if no cat is a pig, it also means that no dog is a pig. So this also becomes a valid argument. And your answer is C. Because A and B were invalid and C and D were valid arguments. Yeah. So how was that? Was that slightly more difficult, slightly longer? 4 syllogisms in one question. But was that also fun? Yeah. Anyone who's not understood? Acha. So C will like to be repeated. Huh. It's okay. Take your time. See, this is a new topic for some. And the way we are going about it is the way for understanding. Okay. The faster way is to do it mentally. But first practice with diagrams. When you practice with diagrams, with practice, more and more practice, it will become here in your mind. Okay. So let's clear the slide first and I'll explain C again. No poet is a thinker. So we have two mutually exclusive events for poet and thinker. And what we are told is these two can never overlap. No poet is a thinker. There are no common elements within them, right? And some thinkers are leaders. So let's use this same diagram and extend it with leaders. And this becomes those thinkers who are leaders, right? So some thinkers are leaders. Now, we are not given the relationship between poet and thinker. We are given the relationship between poet and thinker and leader. But what about poet and leader? That is not given. So leaders can be here, leaders can be here, or leaders can be here. And all of them will have some thinkers who are leaders. This overlap always has to be there. But in this one, there were some poets also who were leaders, which is okay. It's allowed in case this is leaders. But poets and thinkers cannot overlap. So this circle for poets will never overlap with these dark blue areas who are leaders who are also thinkers. There will always be some leaders in these dark blue areas who will not be poets. These are the thinkers. Yeah, these people. They can never be poets because they are overlapping with thinkers and no thinker can be a poet. So there will always be some leaders, those in these areas, who cannot be poets. So this becomes a valid argument. Okay. Then a doubt on how should we consider only cats are dogs in the diagram. So only cats are dogs can be drawn with the same circle for cats and dogs. All the contents of this circle are both cats as well as dogs. There is no cat that is outside, which is not a dog, and there is no dog which is outside, which is not a cat. Entire circle is both cats and dogs. This is the diagrammatic representation for only cats are dogs. Right? So Ravindra, coming back to your question on B, why B is wrong? No poet is a thinker and some thinkers are leaders. We are back to this situation. It's the same diagram. No poet is a thinker. Some leaders are thinkers, right? Those are the ones in this purple area. But we are not given the relationship between leaders and poets. That is not mentioned in premise 1 or premise 2. So leaders can be here, which is not overlapping with poets. It can be here, not overlapping. It can be here, not overlapping. It can be here, in which some leaders overlap with poets. So we cannot definitely say that no leader is a poet. It may be true in case we have this one or this one or this one. It may not be true as well in case we have a diagram like this, where leader is overlapping with poet. So this is not specified, and therefore it becomes an invalid argument. See, just try to keep in your mind, if we cannot guarantee that an outcome will happen, it is invalid. Can you guarantee that no leader is a poet? No, because we just drew a diagram in which some leaders are poets, these guys. So we cannot guarantee it, and it becomes invalid. Can we guarantee that some leaders are not poets? Yes, these are the leaders in the purple color. We guaranteed it. They will never be poets because they are thinkers. Okay, so B is also okay. Yeah, 1 to E9 and Ravindra as well. So let's do one more. Yeah, so shall we solve? Anyone who's still solving? That's around 2.5 minutes or so. But take your time. Huh? In the initial few questions, go slow. Even in the exam, in the concept test that we put up, there is plenty of time for the first test. So take it easy, solve each question as we are doing in a diagrammatic manner, and try to figure out which is okay, which is not okay, which follows, which doesn't. So let's start with all music is good. So music becomes a subset of good. And all good is great. So good becomes a subset of great. I'm just using GR and GO because If you use only G, you will get confused. Can we superimpose this on this? If all music is good and all good is great, then we can say a larger circle for great. Right? Can we say this? So music is a subset of good and good is a subset of great. So this is premise 1 and this is premise 2. Therefore, can we say that all music is great? Yes. If music is inside the circle for good, which is inside the circle for great, then automatically all the elements in this smallest circle have to be inside the largest circle, right? So effectively, all music is also great. If all music is good and all good is great, then all music becomes great. So this is a valid argument. Yeah. Then we have all men are wise. Similar kind of situation. All men are wise. And all wise are leaders. All men are wise and all wise are leaders. So each becomes a subset of the next. Can we say all leaders are men? Not necessary. If all men are wise, these are men, they are all wise. But there can be wise who are not men. They are here. And we are saying all wise are leaders. But there can be leaders who are not wise and not men. They are here. Right? So these people are leaders, but they are not wise and they are not men. These people in middle, yeah, they are leaders and they are also wise, but they are not men. And these people inside are leaders and they are wise also and they are men also. Okay, so these are the three situations which you get from these premises. Premise 1 and premise 2. Any doubts here on this one? Everyone with me so far? So can we say all leaders are men? No. We just pointed out leaders who are not wise and not men here. And we also pointed out leaders who might be wise, but they are not men here. So all leaders are men cannot be said. This becomes invalid. Third one is the same diagram. All men are wise. All wise are leaders. Can we say some men are leaders? Yes. In fact, all men are leaders. And that effectively means some men are leaders. These men who are inside the circle for wise, which is inside the circle for leaders, these men are all leaders. So this is okay. If any of you all got confused between some men are leaders and all men are leaders, was there anyone who can't get the difference between this? Right? So when we say all men are leaders, we put men as a subset of leaders. Right? When we say some men are leaders, we put overlapping men and leaders. Men and leaders. And this becomes a subset. Right? But the contents of this part of men who are not leaders, this is not told to us. And suppose if this becomes 0, then suddenly you move this way, where this overlapping part is men. And the rest are leaders. If this becomes 0. So in the absence of this information, when we don't know how many men are there who are not leaders, some men are leaders can be said this way. It can also be said this way. So both options are okay. In some men are leaders. And therefore, although this actually says all men are leaders, it also means some men are leaders. Yeah. So all men are leaders also means some men are leaders, because there will be some men who are leaders. They are all of them. Okay. But some men are leaders doesn't mean all men are leaders. So all men are leaders means some men are leaders, but When you say some men are leaders, it doesn't mean all, because in this condition, what about the others who are not leaders? It's not given, so it's not the same. But if all men are leaders, it can be extended to some men are leaders. So this becomes valid. Yeah, okay. Then we have the last one. All boys are men. So we have, okay, let's clear the slide. Let's put it here. All boys are men. And some men are smart. Okay, so if we have all boys are men and some men are smart, so this is men and this is smart and these are the men who are smart. So can we put this here? Yes, we can say this can be smart and some men are smart. But we don't have the relationship between smart and boys. They may or may not overlap. Right now they are not overlapping, but smart can also be this way. In this case, some men are smart and smart is also overlapping with boys. So whether some boys are smart or not, we don't know for sure because that relationship has not been given to us explicitly. So D becomes invalid. And your answer becomes A and C. So therefore, here, last one is your answer. Right? So anyone who's not understood this one? These are slightly longer. They are not difficult. It's just one argument, two premises, one conclusion. But it takes time. So Ravli is saying that if D is invalid, all boys are men and some men are smart, some boys are smart. But D and C are not related, Ravli, because here there is a difference. Some men are smart, not all men are smart. So that's why we didn't put men as a subset of smart. We put men and smart as overlapping circles. Some men are smart. We don't know about others. There can be some smart who are not men, and there can be some men who are not smart, which is here. Yeah. So while we don't know, it will not be a subset. It will be overlapping. So that's the difference between C and D. Here, all Y's are leaders. Yep. Okay. So we started with a few simpler problems. We just did a bit of warm up, a bit of practice. We went into premise and conclusion, and we tried to identify without Venn diagrams. Then we studied what are Venn diagrams and how to solve these slightly confusing ones with the help of diagrammatic representation. Okay. So I hope this was good practice. I hope this was fun. We'll continue in the next class. I have a couple of more lectures to go with you. One will be on vocabulary and the other one will be on critical reasoning. So I'll see you all again this week. Keep up this energy, keep up this enthusiasm, this class participation in all the classes that we do. Please go to the website, start attempting the tests every day. And those who have not understood, the solution of the test will explain it much better in case you get things wrong. Okay, chalo. So we'll close this class over here and I will see you all in the next class. Bye. Have a good week and please stay safe. Thank you for attending.